Have you ever wondered how an automobile assembly line is controlled? In this video, we're going to talk about what controls large or small mechanical processes like an assembly line. That device is called a control panel. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new Real Parts videos. This way, you never miss another one. Think of a control panel like the human body. Inside our bodies, we have vital organs that control and monitor our surroundings. Similarly, a control panel is a metal box which contains important electrical devices that control and monitor a mechanical process electrically. Let's get started. First, let's talk about the enclosure, the metal box that contains all of the electrical devices of the control panel. Enclosures are often aluminum or stainless steel, and the size will vary based on the size of the process. A control panel enclosure can have multiple sections. Each section will have an access door. The size of the enclosure is commonly referred to by the number of doors the enclosure has. Each enclosure will have an electrical safety rating designated by UL, the Underwriters Laboratories, who governs electrical safety. They will also have an IP rating, or NEMA classification, which designates the enclosure to be indoor or outdoor, waterproof or water-resistant, suitable for hazardous conditions, dustproof, or explosion-proof. Now, let's go inside the enclosure and talk about the non-electrical components that make up the control panel. First, let's talk about the back panel of the enclosure. The back panel is a sheet of metal that is mounted on the inside of the enclosure that allows us to drill mounting holes for different devices, which leads us to our next component, DIN rails. A DIN rail is a metal rail with a standard width used for mounting electrical devices inside. The next component inside the control panel is wiring duct. Ducts allow us to route the wires in an organized and efficient way, while also reducing electrical noise between devices. Next, let's get into the electrical components of the control panel. The main circuit breaker is where the power comes into the control panel for all of the devices. This circuit breaker generally has a disconnect on the outside of the panel that allows us to shut off the power. Always remember the top side of the circuit breaker will still have power. The power that comes into the panel can be anywhere from 480 volts to as low as 120 volts. After the power comes into the panel from the main circuit breaker, the power will be run into a surge arrestor. A surge arrestor is a device that protects all of the electrical equipment inside the control panel from electrical surges or overvoltage. An electrical surge can come from a lightning strike or utility power surge. The power can be connected into a transformer that switches the power down in order to power smaller devices. If the incoming power is above 120 volts, a transformer is generally used. If the power is 120 volts, a power supply can be used to step the power down to 24 volts. Now that the control panel has incoming power from the main circuit breaker and power distributed by a transformer or power supply, the different voltages can be wired into terminal blocks for even more routing of power throughout the control panel. A terminal block consists of two terminals that can join two or more wires together. Terminal blocks can be arranged with several other blocks in a strip mounted on a DIN rail to run power from one source to several devices throughout the panel. The final part of the control panel are the devices that control and monitor the mechanical process. Let's talk about the PLC, or Programmable Logic Controller. The PLC is like the brain of the entire process. The PLC will have a CPU where the logic program is stored. It will have associated inputs and outputs, which will help control and monitor the assembly line. Speaking of our terminal blocks, we will have wires running from them to our inputs and outputs. This allows for the actual control of the assembly line. Field devices, such as proximity switches, photo eyes, and other sensors, are set up on the assembly line to give the feedback needed for the PLC to control the operation of the line. The PLC outputs will be wired to a bank of relays that will close an internal contact that will send power out to turn on or off a device on the assembly line. Smaller relays will control devices such as lights or fans, while a bigger relay, called a contactor, is used to control motors. We will also have a network switch located somewhere near the PLC. This will be powered with 24 volts, and it will be the hub for our communication to and from the PLC to network-compatible devices on the assembly line. One of those devices is our Human-Machine Interface, or HMI. An HMI can be mounted locally onto a panel door or in a remote panel located closer to the machinery. The HMI can be a very dynamic tool in assisting the operator in controlling and monitoring the machinery. The PLC will pass signals over the network to the HMI for monitoring, and the HMI can send signals to the PLC for controlling the machinery. Today, we talked about the components of a control panel. Each control panel will have the main power source coming in that is distributed throughout the panel to varying devices for control and monitoring. Control panels will come in different sizes, but they all have similar devices that we talked about today. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.